So changing the password in the vehicle.py for the embedded
Yeah.
domain,
Yeah.
that's going to be first of all, you would never probably have a password change in that, right? We did a little bit of hand waving when we put that in the vehicle.py. And really, what you'd end up
Okay.
doing is you would actually implement provisioning flow for the vehicle, meaning at some point, and the provisioning flow would actually happen probably at the factory on manufacturing. So as it's going down the line, whatever gateway box or whatever IoT, telemetry box or whatever has that radio on it, probably that
Hmm.
gateway, what we call the gateway, uh,
Okay.
that would probably be outfitted with a pair of credentials. Typically, they're
Okay.
certificates, right? And those
Okay.
certificates are already paired with some entity in the
Hmm.
in the cloud, meaning
Okay.
there's a record in a database that says this vehicle, this gateway box, basically is paired with a vehicle. And even on
Mhm.
manufacturing, you may get to the point where you're actually pairing a VIN with that, which would be good
Yeah.
at that point, right? Really depends on that provisioning flow and why IoT is so hard. Is at
Okay.
what point can you do it? There's a million different right answers and a million different wrong answers too, right?
Okay.
So
Okay.
um, the I think the challenge really is designing that for purposes of our boot camp. We just said, look, we'll make it easy. We won't do a separate authentication flow
Hmm.
for the vehicle. We easily could. We could easily do a key secret or a certificate,
Hmm.
something, right?
Okay.
Um, Coordination between the embedded domain
Hmm.
and the cloud, and then that specific route, all the routes that the vehicle communicates with would basically use
Hmm.
that authentication flow. So instead of
Okay.
securing it with a username and password, right,
Yeah.
you would secure it with your embedded authentication flow, which would be a certificate or something, and that vehicle would have its own identity at that point.
Okay.
Certificate
Okay.
pairs. And then how does that vehicle belong to a user, right? A username and password.
Yeah.
That's just a
Yeah.
record in the database. You're right.
Okay.
I mean, you just have a link, what we call a link table,
Hmm.
and that link table has a user UID and it has a vehicle UID in it, right? Or a vehicle
Okay.
user ID and a vehicle ID. And as long as
Okay.
that pair exists,
Got it.
then
Yeah.
your authorization, everything can be checked against that.
Got it. Okay.
Make sense?
So yeah, user password, I got that. So say I don't know whether this sequence will happen, but just a weird question. So at some point, the customer want to change the domain itself, right? In that case, how that vehicle, because it's already embedded, all the information is brought into the embedded system, right? How we can able to link that is using a MAC ID. I mean, similar to something like MAC number, or how.
I mean, those things can be spoofed. So what are you saying? What's could potentially be changed?
So the domain, the whole domain name, so it got
Oh,
changed,
right,
or
the domain.
yeah,
Oh, geez.
yeah,
Yeah.
yeah.
Yeah, you probably don't want to do that.
Okay,
um, so
okay,
yeah, I mean that's one of those decisions you make. There is a way to do it though.
okay.
Um, the way that I would do that is I would that would be a massive migration. So let's say you
I
have
see.
like a million units out there in the field, right?
Hmm.
This has happened once before. So let's say you have like a million units out in the field,
Yeah.
and you're like, and your customer or your client, whoever you're building this IoT system for, your company, whatever,
Hmm.
says, "Up, we're rebranding. Now everything
Hmm.
has to use this specific
Yeah.
domain name."
Hmm.
Now you might say, "Wait, guys, does it really matter if my device uses this domain name? No one sees it. The only thing that sees is the IoT device.
Yeah.
And is it really that important?" And let's say the marketing people get involved and they say, "Yes, everything must be branded the way we want it to be." So you're like, "All right, whatever." So we're going to go on a massive month long, multi-month long sort of migration. And
Okay.
what you would do is you would do what we call OTA, over the air updates.
Hmm.
And what you would do is you would push down a firmware version that
Hmm.
would check. First of all, it would have basically a primary mode and a failover mode.
Hmm.
The primary mode would check the new domain,
Okay.
right? And then the failover mode would fall back to the old domain. And what you would do is you would make sure that you would have overlap between the new domain and the old domain. And as you know now with Nginx and everything, you could have
Yeah.
the new domain and the old domain point to the same place. So it could
Yeah.
literally be the same place. It's more of just the doorway, right?
Okay.
But the two different doors could go into the same building, right? So
Mm-hmm.
that's kind of what
Mm-hmm.
we're talking about. So from that perspective, I would probably do a failover where I would try the new domain. If the new domain isn't there or isn't working, then I would fail back to the old domain. And
Okay.
then if that doesn't work, well, then you've got other issues, right? Eventually, what you can do is you can log then, and you can
Mm-hmm.
see from all of your devices out there if you can slowly see the attrition from the old domain, the checking against the old domain, because your logs would say,
Mm-hmm.
hey, how many things are
Mm-hmm.
coming through, how many requests and transactions are coming through this old domain, and then
Mm-hmm.
how many are coming through the new domain, right?
Okay.
Eventually, you'll see all of your devices, assuming they all get the firmware update. That's the key.
Okay.
That you'll eventually see zero traffic on your old domain, and
Mm-hmm.
then or traffic you care about, and then you can say, all right, we'll shut it down. No one's
Okay.
using that anymore, and it would be a very long migration process, right? Because you do structured rollouts and all that kind of stuff, right? With
Mm-hmm.
sections of your firmware, you'd have classes of your firmware. Now, some of the time, what I've seen from like old deployments and stuff, old IoT deployments where they didn't quite think things through, they
Mm-hmm.
didn't allow that part to be updated with their devices, right? And that's why it's
Okay.
so important for OTA and firmware updates to actually make sure that you're doing the right things and thinking ahead. And that can be a really bad thing if your firmware updates and your OTA does not allow you that type of fine-grained control
Mm-hmm.
for updates, particularly from a security standpoint. Let's say your
Yeah.
domain is compromised, right? And
Yeah.
you literally cannot figure out why everything is being rerouted. Maybe your
Yeah.
registrar got hacked or something. Who knows, right? Like the worst of
Yeah.
the worst. At that point, you got to do it really fast, right?
Mm-hmm.
I mean, you got to push those out as soon as you can so that that stuff gets switched or changed.
Okay.
Or really bad, which is a more common problem, is a mistake, and that mistake is that you don't renew your domain registration. And
Mm-hmm.
this just happened with one of our enterprise clients. They didn't renew their domain registration in
So
time.
you lose your domain name,
They
right?
lost
Yeah.
their domain name.
Mm-hmm.
The registrar lost it, put it back up for sale immediately. It's like an automated
Mm-hmm.
process, and it literally took a month and a half to get
Okay.
it all back working. We fortunately
Okay.
had updates abilities, so we were able to get the update and everything and do that. So
Okay. Okay.
let's give me just 1 second.
Sure. Sure.
My
Sure.
my dog needs me.
Sure. Sure. Sure.
Right, that's strange. She never does that. I don't know what his deal is. But yeah. So, anyways, the firmware we haven't really talked about OTA because that's more of on a embedded
Mm-hmm.
side. But and it really that can take so many different forms because the the idea is that if you have a low power device, like a resource constrained device where you're not even running an operating system, that can be a pretty frustrating thing because you don't. While you can totally reflash the entire thing, you have to be conscious of memory constraints and how much did you double the space on it? Can you actually do a larger image to do the flip over and all those details? We could talk about how that strategy goes maybe in another boot camp, right? Like an embedded boot camp, because that's a whole nother deal.
Yep.
On an OS, it's a little easier because there's a lot of infrastructure already built up that you can kind of latch into to do those updates. Particularly if you're using like a Linux-based system, you can use the packages, the package managers and all that kind of stuff to really do that. We've done any number of full ranges of devices, all the way from tiny little things that barely have any memory
Mm-hmm.
that are updated over, a spy bus, all the way to a full-fledged Linux machine where you're working with the package repositories and managers, and it's just a simple check and it's installed and you reboot and you're good to go. It really all depends. So yeah, I mean, from that perspective, I think um,
Doable, but with a lot of pain.
it really depends on how much you've thought through your OTA, your over-the-air updates. Um, and
Gotcha.
yeah, that's what makes firmware, that's what makes IoT really hard, because it's one of those things that's always an afterthought, and it
Mhm.
shouldn't be. And it's one of those things people don't necessarily think about, or it's one of those things people say, well, it's an edge case, but it's one of those things that always starts rearing its head immediately. It's You can't do without it, right? There's just no a good IoT network. You just can't do without it, and no one has a good solution for it. That's the problem. Like in AWS, GCP, all these managed IoT platforms,
Mhm.
uh, working with an embedded platform and being able to manage all those embedded platforms is so many different types of them, that you really can't provide a one size fits all sort of solution. They have certain solutions for like Android. Like Android's got a really nice system, but that's if you want to run Android, which is a power hog and a pretty beefy sort of thing. Do you really need all that? No, for most IoT things, you don't need that. So, yeah, it's that's a really difficult problem to do, and they're pretty custom. That's just the nature of the game, and they will be custom until someone's figured out kind of a one size fits all kind of thing that you're able to just kind of manage the energy
Yeah.
and the processing and all that kind of stuff. And we're still pretty far away from that.
Yeah. Yes. And so just a hint, I don't need the answer, but just a hint. So do you use await async on the vehicle.py too, in order to get that async, flow?
You can if you use Python's async await,
Mm-hmm.
which you can. I mean, that's
Okay.
built in with 3.6 and above. You can try that.
Okay.
That would be interesting to see if that would work. Um,
Okay.
Typically, in what we do in Python, from an embedded standpoint, we actually use threads.
Okay.
And so, what you probably know what threads are conceptually, but really, what a thread is there's three different types of concurrent or parallel programming.
Mm-hmm.
The first one is processes. So if you have an operating system, you can basically spawn new processes, and that's where those are different programs. That's like Microsoft PowerPoint, Excel, and Word all run at the same time. Like totally different processes, have nothing to do with each other.
Mm-hmm.
In Python, you can spawn a new Python program. That's a separate process. Typically, you don't want to do that because of the complexities with trying to do that. Plus, if you're spawning one process from another, it's kind of like, well, you probably want that process to communicate. So if you spawn it, then there's communication. The second way is threading.
Mm-hmm.
Threading is a very difficult thing to do. The API is very simple. It's just Python threading, but you run into issues with concurrency and critical, what we call critical memory sharing, and all of those different things that really start to get deep into the details. Which, on the surface, usually they're not a big deal. But if you want to do anything other than the simplest kind of concurrent programming, meaning threading, um, it gets you can get some weird behavior that is
Okay.
unexplainable sometimes.
Okay.
Um, the third one is asynchronous programming, right, where everything's on the same thread,
Yeah.
right? It's in the same CPU kind of. It's very serial linear. It's just a matter of, um, you know, uh, execution, right?
Yeah.
So threading is really powerful if you have multiple processors, right?
Mhm.
Asynchronous is really powerful if you only have one processor, because you literally are just having single flops that you can basically take advantage of. So in Python, typically, traditionally um, we've done, um, you know, threading, I guess,
Mhm.
on the embedded side, because we're using like Docker and those types of things, even on the embedded platform on some sort of stripped down Linux. Um, but even on really resource constrained devices, like a microchip PIC32 or something, you'll sometimes do a thread like interface.
Okay.
It's more asynchronous in implementation of the hood, but you might think of it in terms of threading. Um, and so, from your perspective, You can try asynchronous. I'm not. I mean, you'll get what you want with the asynchronous programming. The issue with asynchronous programming is requests. The library that you use is not asynchronous, and so you will probably have to find an asynchronous request library, HTTP library, because request implements URL lib, which is not asynchronous. There are I'm sure there are asynchronous Python libraries that are asynchronous. You may try threading, where you actually will just say, look, just put this off on the thread. Like it's like, hey, I want you to send this. I know you're going to take some time, so just let the thread handle it and let it do as fast as it can, and then it allows your outer loop, your actual simulation, to keep going. Right now, your timing isn't going to necessarily line up, but you'll probably get pretty fast that way. And that way you can simulate as fast as possible. The thing you have to be concerned about though is your thread is always going to lag behind your simulation, right? And so you have to wait to make sure that your communication thread is done at the end, which you may not see right before killing your simulation. You may not actually get all your data in, right? So there's all of those things. It's a bit of a mind game sometimes with threading.
Okay, I will try. It sounds interesting.
Yeah, check it out. It is cool. It's fun to kind of think about and stuff. But those issues it gets really real in that stuff when you get to threading and those types of things.
Thanks, Vijay.
Yep. Any other questions?
Vijay, hello.
Yep.
Hey, Vijay, hi. A short one, a quick question. You
Yep.
know, before we introduced the database, while we were provisioning the vehicles and posting the data, you often used the term in-session memory. And when we talk about in-session memory, are we talking about the in-session memory of the server here in server, which we have created within Docker, or is it at the client end? I mean, within the browser, because I understand in the browser in-session you have local storage and then cookies. So
Yeah. Yeah. No. Good question. So actually, the word session. I hope I didn't use that word out of turn because we don't actually use any sessions. You may have read about sessions,
okay.
but we don't actually use sessions on the
But maybe,
server side.
yeah, I take my question back. You may have said maybe in memory or something like
I
that.
probably said in memory because
In memory, yeah. Okay.
before the database stuff, right?
Yeah, before the
Yeah.
data.
It's in memory. Yeah. Oh, yeah. Because you can. I mean, all a database is a data store, right? That's
Correct.
that's
Yeah.
all it is. And so you can choose to store data in memory. In fact, that is the fastest possible thing you can possibly do, right? In fact, if you want as quick access as possible, you want to store stuff in memory. And that's kind of what Redis does. It has algorithms that make sure that your data is as close from a memory perspective and access perspective as possible. That's kind of the beauty of it. But you'll notice there's no silver bullet in this, right? So Redis, you don't want to store a bunch of data in it because it's optimized for that really quick read write thing in memory. Um, and it might actually use sessions type stuff, right? So it will keep cached memory to say, all right, you've requested this a number of times. I'm going to keep this on the forefront so that I can send it as fast as possible, right? Um, so when we say in memory, yeah, we're just storing that basically in a hash map or an object or something in our server. But the problem with memory, of course, is it's very volatile. You lose it, right? When you power cycle, when you restart, those types of things. So that's one of the things that you want to be considerate of when you're thinking about how you store your data. Do you do it in memory? And a lot of times we do it in memory. The other thing that that in memory never helps you, particularly on the server side perspective, is we'll get to this not this week, but the next week at week 12, because we're only 2 weeks left, when we talk about advanced deployment, and that is how do you scale systems. If you can think, we've kind of touched on this a little bit, but you can think, we have our gateway, right? Or cloud. We call it a gateway, but our cloud server. If you have extremely heavy load, you're going to want to spawn new versions of this cloud, right? of our process because it need to handle multiple requests. If you notice, we've made it completely stateless, right? By adding that
Mhm.
database, because everyone's going to be pointed at the same database, but as long as the requests go through and hit the database, and the J2T tokens are completely stateless, right? All the information is stored in that J2T token. You can basically scale these cloud instances infinitely, right? What we call scaling horizontally, because you can just keep doing, and then your load balancers like Nginx will just point to the one that's available, right? And then you'll just
Yeah.
keep going, and then your databases can scale and all that kind of stuff the same way horizontally. So the issue with in memory, right, of this horizontal scaling is that you can't actually store stuff in memory but have it accessed by everybody else, right?
Yeah.
Because if each one of these are Docker containers,
Gotcha.
well,
Yeah.
they each have their own memory space, and they're all each using it individually. And so, if you're just storing stuff in memory, even if you have infinite memory, um, you're still going to have a problem that if you have to scale horizontally, they're not going to have access to that memory, which is why we always push it to the database. Now, there
Makes sense.
are there are memory store databases like Memcached and Redis, which kind of function as that distributed memory, but they're not implemented the same way, right? As just setting a variable in code, because you just can't do that, right? So hopefully that kind of answers
Yep.
the question, but it's mostly server side. You might hear us say like session in the client side context, as it relates to cookies or as it relates to like local storage, those types of things. Sometimes we'll say session when we mean like the valid J2T token time or something like along those lines. But typically, when you read something that says session, it typically is doing it in a somewhat old way of implementing web services, and that is where the server is actually keeping a session open, and so it's very stateful. It's literally keeping a session open and knows the communication back and forth between the client and the server is a single what we call session. So it's actually keeping some hash or something of this session, and this information is going back and forth, and then you can maintain authentication and authorization and all that kind of stuff with the server. And that's where like cookies come into play and all that kind of stuff. As you notice, we don't do any of that, and the reason is because you can't horizontally scale that very well. In fact, you just can't, which is why everyone's moved away from that, and moved more towards to a stateless authentication and database structure, like J2T tokens, things like that. Justin,
Thanks.
you want to add anything there?
I think when you're talking about stuff being in, use the word session or in memory, the important thing is to kind of understand where your code's running.
Yeah.
You know, um, it can be confusing because you've got so many moving parts. You've got, your local computer, you've got a server out on the cloud. You also have different places within your same local computer that processes can run. Like, is it running in your browser, right? Or is it running in a node process that's on your host machine, or is it a node process inside of a Docker container, right? And I think that's something that it's a good exercise whenever you're actually running a connected system like the ones that we write, to stop and think about physically what machine is using its electricity to make that logic happen,
Mm-hmm.
right?
Yeah.
Like what's energizing that process, right? And if you can answer that question, you'll have a really good grasp of how the things are distributed.
Yeah, that's a good pointer. Yeah.
Yeah. No, that's a really good point. Yeah, it's about that systems holistic approach to it, right? Design. You always got to think about the systems that you're designing, or else you will go down a rat hole and you won't be able to get out of it.
Which is why we were talking about what we were talking about malware showing up in client-side JavaScript one night, right? And how if you knew how to inject some kind of nefarious code that you wrote into a plugin that got super famous, or maybe a library that a lot of people ended up using, you could manage to get your code to do something using another person's computer, right? Because the moment that it loads into the browser, even though it's a website, right, the browsers all run on local machines. It's kind of funny because it's like it's very rare that that the code for a client-side code for a browser would run on a server. Correct me if I'm wrong, but I can't think of very many cases unless you were doing some kind of remote desktop into a server and it was actually showing you its browser that you're then viewing through a remote desktop connection. But the vast majority of browsers run either on your laptop, on your phone, on a tablet, etc. Right? So if there's any kind of nefarious code that's running in a browser, you're essentially able to use somebody else's processing power to do something you want, which is why it's common to hear about Bitcoin mining.
Right. Yeah, exactly. Yeah, it's a difficult thing to get around for sure, and something you always have to plan for. It is very difficult to hijack a browser code though. It's not necessarily that easy, and it has to be pretty insecure. I mean, the browsers do a pretty good job of sandboxing. There's a lot of walls before you have to really try to take down the security, kind of the custom or the. You have to really try to make your site from a just pure client side, not backend, but pure client side, so insecure that someone can take advantage of it. The tools and everything are built up in a really consistent fashion, and the browsers themselves have safeguards to allow this thing. Even like local storage, you can't access it if you're on a different domain. You only access it on the domain that it's coming from. It's like things like that that make it pretty difficult to take advantage of something. And it's probably one of the most heavily researched from a security standpoint um, platforms, right? Because so many people use it, and it's also the easiest to figure out. So um, if you don't see a massive like bug or security threat or something, it's um, um, it's a pretty you just probably aren't going to see them very often. And if they exist, they have not been discovered yet, because you would hear about them. It'd be pretty tough to keep that quiet, to keep a really big exploitation or something in the browser quiet. Just too many eyes on it. And the fact that browsers, most of the browser platforms now, which is basically Chromium, Google's open source project, that's the browser that the browser engine that pretty much everything's built on now, other than Firefox and Safari. You've got Chrome, even Microsoft's new Edge is built on it, and all the other browsers that you see out there are built on Chromium. It's open source. There's a lot of eyes on that, so it would be pretty rare to find something like that. You might find something in Safari because it's Apple, it's closed. You might find something in Firefox, although Firefox is also open. So you'd be pretty hard pressed to. There's just so many eyes on that stuff, right? That, um, yeah, that there's not a lot of area there anymore for exploitation and bug bounty kind of stuff.
Are we going to discuss anything today?
I didn't have anything, so it's basically just open for you guys to ask. I mean, we can also be done if you guys are cool. If you guys don't have any questions, then let's call it a night. Um, we are doing something really cool on Thursday. I'm looking forward to it. It's probably the coolest week yet, and we've had some pretty cool weeks, so it's a tall order.
Just
Yeah.
sure. Just one question, maybe before we call it for the night, and it's more for Justin or even BJ. You can explain. I mean, when we see Justin, take us through the coding like last week's session, or it just seems like he may have rehearsed it so many times. While we know he wouldn't have done it, it's just his expertise and knowledge. But is there a tool that he that is available where perhaps if at all, wherein you can plan as to how your uh, at maybe not completely at a macro level, but maybe a little detailed level as to how your code is going to flow, right? Uh, is
Yeah.
that something you use, or is just the experience? I mean,
It's mostly experience, but typically there is something that you might want to look into. It's called UML, Unified Modeling Language, um,
okay.
or SysML even. UML is let me pull it up here. Um, UML is basically an industry standard for it's a modeling language. Really, all that means is it's just yet another language, but it's not actual language. It's graphical, right? So there's boxes, and there's a very specific way you can do things. There's many different things like different diagrams. There's structure diagrams, right, where you actually have like components. You probably have seen these things, right? Especially in automotive, they'll
Yeah,
do things like
flowchart. Yeah,
right.
yeah.
Um, Honestly, I've never actually seen a correctly formed, like truly valid UML because there's like a billion different ways to do it. Mostly what we do, like if I'm trying to think of how to do something, I basically just whiteboard it, like I've kind of done with you guys. And you just kind of flow. But yeah, it comes with experience, right? But it
Yep.
also, um, that's also kind of what separates us and why we like to teach to engineers, because you guys are already used to thinking in terms of systems, right? And how things come together and everything. We're not fighting that uphill battle with everyone else who doesn't necessarily view the world in systems, right? And so from that perspective, I think generally we tend to I think we tend to generally maybe assume too much sometimes and how the systems are coming together. But at the same time, it's also a good exercise to kind of see how they come together organically and then construct those later, which is also kind of intentional from my perspective. And the reason is because it forces you to basically try to put them together and draw your own system conclusions about it too, right? But if you're looking for like a tool, sometimes you'll refer to it, I think, like meta modeling or something. It may actually even be in here. Oh yeah, it's like the next one, right? Things like that. You'll hear words like that. Um, and there's lots of different software platforms that allow you to do this, right? I mean, even Visio has a whole probably UML library. So if you've ever used Visio before, which I'm sure you have, um, you know, you could probably use UML stuff for that. And then there's a superset of UML called SysML, which I've used before. Um, and SysML is basically an extension of UML that includes other things like the ability to do code generation, which is kind of it's the holy grail, and it's not possible and has never worked and will never work in my opinion. But it's done by INCOS, really supported by INCOS, which is the systems engineer kind of society. So like when I teach at University of Texas at Dallas in systems engineering, we do a lot of we pull from INCOS books and things like that, and we teach SysML and UML as kind of a basis framework. Um, but I promise you, when you get out, no one actually uses UML or SysML religiously. Because it's too hard to keep it up to date. Once the project starts, things change, so you pivot all those different things all the time too hard to keep it up to date. So typically you'll have a bunch of nice UML architecture diagrams that were only valid at the very beginning of the project. That's how all projects go, right? So that's kind of how it works. And that's also probably why we don't necessarily like focus on diagramming or at the high level at first, because we know it's going to change. And the thing is, as we go through, especially when we're teaching this, like to you guys over the last weeks, I mean, we have a general idea of what we're going to do when we go into it, but doesn't necessarily mean that's what's going to happen in the end, right? And so it can be pretty flexible, as you know, right? You see, why does this not work, right? You see us trying to debug things in the middle of it.
Yeah.
So that's really kind of the flow, but it really comes down to experience. Um, and you got to do a few of these systems. You got to think them through a few times. Like this system, this is your first one that you've thought through. We touched on a ton of things, but even Ariv at the beginning of the office hours was asking about questions that we didn't cover. Things like over-the-air firmware updates, and what happens if a domain name changes, or you have to change it. Like, how do you do that migration? Is there a migration? Can you even change it? I mean, there's so many different things that you have to think through. But now that you have the tools, right, you can go research it and you kind of know the words to go and look at, right? I mean, that's kind of the thing. But there are no two systems that are the same. And it's the best diagram that I can give you is that one that I showed you in the very beginning. And it's the three things, right? Cloud, embedded, client. Every IoT system fits in that, but then everything else underneath of that just totally different. So good luck, right?
Yeah, and my gut reaction to that question was I was actually looking around here to see if I could find a whiteboard somewhere. I mean, it's directly where you go when you start thinking about how you want to set up a system, right? The nice thing about a whiteboard, I feel like, is just the restriction of constraints. Like you can grab a marker, put it to a whiteboard, and you don't get bogged down by the details, right? You can kind of in a foggy manner start to delineate your system. On top of that, I think personally I like to think in interfaces, right? So, and a lot of the discussions that we
you,
have are
you
about
would
the inter.
you would JC because you came from Java.
That's exactly what it is. Yeah. So I mean, and when you think about the interfaces, right, of between the different parts of your system, then you get those well defined. You are able to kind of do this hand waving where you can say, look, I know that I'm going to have this device that does X, right? I don't know exactly right now. I haven't sat down and I'm not going to plan out exactly how to do this action, but I'm just going to trust that I can get there. And if you get to that point, you can get these kind of high level graphs put together without getting caught up in the weeds, right? So you do genuinely get to the point where you can see the forest. And I think that is the help and the benefit of using a whiteboard.
Yeah, yeah,
Yeah.
But
yeah. I use whiteboards almost religiously. I mean, with COVID, it makes it a bit more difficult, but it's really whiteboards are your best friend from an architecture perspective.
Yeah, on the same lines, I had a doubt. Like when you start a system, like in design, you would first, though you have to design it on system, but on paper you'll make a layout for any kind of like physical design. So when you design a system, do you ever sit before and you plan? Like, because when we started with cloud, client, and embedded,
Yeah.
and one by one things like first 2 weeks seemed okay. That's it. It's only three. Then it kept adding, and it just kept adding. So how does that work? Like, does it like first do you plan it on paper or it's all
No,
it's
typically you plan it on paper.
you do
Um,
plan on paper?
Usually you plan it on paper, and if you remember when we first started, I think it was the first week, we actually did go through with everything in there, but we also have to be considerate of the fact that there's a ton of stuff, right? And so if we just throw it all on without those nice three little things, then
And
it's
later
almost,
came API, then came the hydrators, then
well, the hydrators, like that kind of stuff, that stuff you don't diagram, because those to me,
yeah.
diagrams are for architecture. Hydration is an implementation detail. Um, with that said, hydration is a implementation detail of your APIs. Do we? So, JC, here's a good question. Do we sit back and we design all our APIs from the get go on a project? No,
No.
never, never. It's too much. Like it's just too much. There's too much creative process that goes in, and too much pivoting that goes into designing a product. Just as you know, from a mechanical perspective, if you've ever designed a vehicle in production, you know that you can do your best job, and we've gotten pretty good at making sure a design happens. But the reason it takes 5 years to actually get a vehicle out into the public because there's tons of iterations because things never go the way you want, right? Same thing with aerospace, right? Or Eve. I mean, it's just so much. It's kind of the same thing. Same thing in software. Just the time frames are really compressed. It's We don't find it very valuable use of our time to start to try to map out every single little detail from an implementation perspective, like all the way down to the nuts and bolts. No, we're not going to put like, hey, there's a J1 there, or there's a, we're going to, use this type of, I don't know, sizing or whatever on this. You do your best initially, right? But from our perspective in software, because the timeframes are so compressed, we don't do that initially. We just attack it. We have a general idea, high level of the architecture that we're going to do. We have a general idea of the REST APIs that we do. We sometimes go through what we call a service design, where we draw our three domains, right? And then what we'll do is we'll draw arrows. We'll say, all right, when a user gets his device, what happens? All right, draw an arrow. This is the restaurant we're going to hit, and this is some of the data. But it's like chicken scratches. It's like barely put together, and then it's like, all right, he gets an arrow back of information. What does he get back? He gets like 2 of these fields. We know that there's a hell of a lot more fields he's going to get back, right? He's going to get tons of things like UIDs. He's going to get created times and those types of things. Those we'll figure out later. But then we'll say, all right, what's the next step in the process? All right, well, then in the cloud this happens, and then this the embedded domain gets a notification, and this is the data that flows there, and then we'll number the steps, right? And then you just get this mess of stuff, right, in the service design. And then at least at that point, you've kind of thought through generally what's going to happen. At that point, you probably still don't have a really good handle on exactly what's going to happen in the system, and that's okay. That's by design. Because at that point, you just say, all right, I generally understand that I'm not going to go off onto some random tangent. I'm just going to dive in and start coding this thing. And the beauty of code, which you don't have when you're actually doing mechanical design, especially a very expensive thing like a vehicle program, is that you can change things really freaking fast, right? I mean, in a matter of hours, days, minutes sometimes, you can totally change an architecture, and no one will have known the better. And so that's why it's much lower risk, and why we don't necessarily map everything out to the details, like what does our hydrators look like? What does that look like? All that kind of stuff. In fact, we don't always even draw out what kind of database technology we're going to use, because we might say, look, we know generally we'll use a relational database here because the data is well fit for relational data. Or we're going to use NoSQL because we need the flexibility of that. Okay. We'll figure it out when we go, and we'll see what the development team tools they're most comfortable with, what's going to scale best, how, what we even think, is going to be reasonable, right? From a maintenance perspective, all of those things that go into it, and that comes with experience. And the experience comes from reading a lot, because guess what? The internet is a great source for this. People have written tons and tons of Medium articles, and they're real short, real sweet things. You read 3 of them, and you could probably make up your mind about it. You could say, all right, 3 people have said this. I'm pretty confident this is the case. Oh, like they're all, and then you read 3 others and on a different subject, and all 3 have different opinion. All right, no one's figured this out yet. I'm just going to go with it. I'm going to figure out what is best for me. At least I know that they haven't figured it out yet, so we'll see. So it's that type of thing. I would definitely, in software, which is really different than mechanical design, I would really caution you to try to draw everything out from the beginning, because it's all going to change, and it's so easy to change and so low cost to change at the beginning of a project. It gets worse and worse, right, as you build. But at the beginning of a project, and if you do it simply, like we've been trying to teach you, where it's very straightforward. You're not putting a bunch of abstraction. You're only abstracting to the level that you need to at each point. then it's going to be much easier to change and pivot more quickly in it, as you go down the path there. So your path of product development. So from that perspective, I would caution you to not draw everything out from the very beginning, to just kind of take it as it comes, and just kind of go with it, and shift it. And at the end of it, then you can go back and say, all right, what did I do, right? And then that's at that point, that's when you start switching into maintenance mode. That's when you drop your architecture diagrams, because they've been pretty much set in at that point. At that point, you either hand it off to another team, maintenance team, or you go into a maintenance mode with your team. And that means, all right, now I understand what we actually have. I know what areas need to be worked on. I know what areas are good. At that point, then your architecture becomes really critical. And so at the stuff that like JC and I do, we really like to be on that very front end of things, where we're just rapidly developing something, and then a maintenance team will take it after us. And so we know that how fast things have to move and change, and we don't typically draw everything out initially, all the way from all the layers that Rachana you were describing, right? You've got your API layer, you got your security layer, you got your hydrators, you got your database access connections, you got your databases, all that kind of stuff. No, we kind of take it as it comes, and if you do enough of these, you pretty much use the same tools, um, you know, over and over, and you might try a new one out every so often to mix it up, things like that. Because for every tool, there's 5 more right behind it that probably do the same thing. So yeah, hopefully that kind of answered your question.
Yes, yes, it did. Yeah, thank you.
So maybe after, once the project is over, you will include in the documentation what are the tools you use and everything.
Exactly, and you'll put your nice diagrams up on how things communicate, and you'll probably document your APIs, which, as you noticed, we actually document all the way through. In fact, we let our open API document generation happen by making our schemas, right? So you're really documenting as it goes through, and so you don't have to like take a bunch of time to go through and then painstakingly figure out what you did. It's already kind of there, and so that part is the tedious part of that is done. You can pass the API docs off in that, and then you draw your diagrams to kind of show how things hang together. And then you might write a few flows, like if there's some weird algorithmic stuff that you did, or certain processes that are somewhat unique because of the problem that you were solving. You may want to document those. But otherwise, as you can imagine, about 90 to 95% of most things is just information passing and contracts with your API definitions.
I guess one thing I'd like to add, stylistically, I feel like as a team we tend to minimize meta work. So we don't do a lot of meta work. Would be like charting some kind of a system and watching the exact progress that you're on while you're there, because that's essentially effort that you're taking away from implementing something, right? So I think I would say that we try to hit a pretty good balance of doing just the amount of meta work that we need in order to stay on track.
Yeah, that's the big thing. My huge thing with the teams that I work with, and Jason can probably attest, is that I always try to avoid as much work as possible, right? And that's not to say that we're lazy, right? We're trying to avoid work. That's actually to say we're trying to be extremely productive, and we don't want to do extra stuff that we don't have to, because there's already always more work to be done. So we really want to minimize, that meta work that JC described. The other thing that we try to do as kind of a rule of thumb is that we'll never over abstract. In fact, JC and I just had a conversation about this a couple days ago, I think. We never over abstract. And what that, you could take that as a simple example of that would be, let's say you're writing some code, and you say, this code, I could make this into a nice function to be called elsewhere, but I'm only going to use it in this one place right now. So do I go through the extra work of trying to define, all the parameters for the function and make it all nice and generalized, right? Generalize the algorithm or something for any case, right? That type of thing. Typically, our stance on that is don't do it at first. wait for the next time you need something similar to that, right? At that point, if you have two things that use that algorithm or that functionality, then you abstract it. But don't do that at first. That should not be your first inclination. I know a lot of great software developers um, who end up over abstracting too quick, and they never actually get any work done because they're too busy abstracting things, and so they're not actually implementing things. They're just writing interfaces for things, and it's a beautiful, elegant architecture, but there's nothing that actually does anything because they never actually implemented it because they were too busy abstracting and figuring out like how to make this so generalized. Not to mention the fact that that overgeneralization, if you do that on many things, even if you can do it quickly, is so difficult to maintain for someone else to come in and try to maintain, and that's the most critical part. Um, is just that someone has to maintain that, whether it's you or someone else. It's really awful when it's you, because I promise you, if you walk away from your code in 2 weeks coming back, it's as good as someone else having done it, right? You're just not going to remember what you did. And I promise, I do the same thing. If I stay away from code for two days and I come back and I wrote it, it's like someone else wrote that code. Like I have no clue. Like it's just that's my time frame. It's like 2 days. Then I forget everything. And so I try to make things as simple as possible so that when I go back, I don't have to spend twice the amount of time as it is to just fix it, as it is to just, understand it and just see it. It's so obvious at that point, right? So really, we don't over abstract, and we try to cut out a lot of the work. Like, we also don't like to have to change one thing in two places. So if you have functionality, right, that happens in two places, then we're going to write one function for that, because we don't want to have to change both things, right? We don't want to copy and paste code. That's part of that abstraction, right? Because introduces a severe issue, and that severe issue is the fact that if you now have two things or three things or more that all depend on this one change, let's say it's a field in an API or something, right? If you change it in one place, then you got to remember all the other places you did it at, right? And the beauty of software is that you can do it in one place, usually, and that it propagates through to everything. Can't necessarily do that in mechanical structures. Like you can't just be like, oh, I'm going to use one abstract bolt and it's going to, cover these four bolts. Like that's not a thing, right? But we can do that in software, and I do definitely push that, because that's where the maintenance thing really starts to pay off. And when someone else comes back through, that's when it really comes for maintenance. That's when it really pays off.
Yeah, that's the essentially the dry principle. Just don't repeat yourself.
Yep. Yep.
Yeah, with having said this, when you're not diving deep into the levels of abstraction, have you ever faced any code density issues or anything like that?
When you say code density, you're just saying like too much code.
Yeah,
I mean, sometimes. I mean, code density issues
but
occur. I think it depends on the language too.
that's something acceptable or something like that.
It can be. I mean, there's some
Mhm,
you just can't do with less code. Uh,
mhm.
that's just the nature of the game. Sometimes it's just a lot of code. Yeah, sometimes when I'm approaching an algorithm and like I have this like elegant like solution in my head, it's like, oh, this is gonna be like 5 lines of code. It's gonna be so awesome. Um, I do it and it ends up to be 200 lines, right? Because like in my head it should be five, but actually there's so much crap around both ends of the actual, the one line of I don't know, your inverse linear system or something, right? So that it's so elegantly simple conceptually, but yeah, there's like 100 lines on either side, right, to set the problem up. Um, that's often kind of the case that I find. So yeah, I wouldn't be afraid of lots of code. Um, Oftentimes, you don't need a lot of code because the languages we use when we typically gravitate towards are very concise languages, and they take care of a lot of the stuff. You'll find a lot of stuff in like C++ and C There's just these massive, nasty like things, and the reason is because it's you have to manage your own memory. There's just so much other stuff you got to do because of the language. Whereas in Python, it's just so concise, right? I mean, it takes care of all that for you, takes care of garbage collection. There's not a lot of verbosity to it. It's just kind of there. JavaScript is a little bit in between, just because of how it kind of looks and flows. But no, I wouldn't generally, as a rule, be afraid of a lot of code. I would be afraid of a lot of copy and pasting. If you find yourself copying and pasting a lot, then you're doing it wrong. Because there's not too many languages that would require you to actually copy and paste something. Very few cases that would actually, where you're like, oh, copy paste, copy paste, copy paste, copy paste kind of thing. And that's a pretty rare thing. Typically, you can put in a loop. Typically, you can do it, in a function, something along those lines. Um, and you should do that to make it more concise. But there are some algorithms, like I said, that are complex, right? I mean, there's just a lot of calculation, or there's a lot of, you know, um, there's a lot of services you got to hit, right? There's a lot of, promises that you got to, go through, and you got to hit a weather API, you got to hit like you know, some sort of prediction model. You got to hit something along those lines. We'll do that on Thursday. There may just be a lot of code in those things. You may have to cache it and then worry about how the caching works, right, with Redis, in order to do manage that from a performance perspective. So yeah, I mean that stuff adds up. So I wouldn't necessarily be worried about that. Whenever I see code density and I'm trying to maintain something, then I run kicking and screaming. But that's another story, right? I mean, what do you think, JC?
I think, obviously, I mean, it's fairly intuitive. The bigger your code base gets, the more man hours you're going to have to put into it. And you're also, you also run into an issue where if it's a giant code base, you're going to have, the issue where you need to have somebody who's got experience with it, it's a lot harder to get up to speed on something that you could call dense in code, right? It's got a lot of complex logic and whatnot in it, especially if it's something that's fairly specific and it uses a lot of like custom algorithms and whatnot, because somebody's going to have to dig through and learn about how they work, right? If it's something that's fairly standard, like, oh, I know that maybe the data model might be something new, but this is using pretty standard CRUD operations. I'm creating, reading, updating, deleting records in here. I see what's going on. So, I mean, I will say one thing. I don't necessarily feel like lines of code is a good measure of the complexity of a code base.
Right.
Right.
Or how productive a coder is either, which sometimes, you'll hear these horror stories of managers like counting lines of code and saying you were productive, and it's like, no, that's not how it works, right?
Yeah, it's so dependent, and I know that this is a bad answer, but the best way for me to describe it would be, one, the actual requirements that the system meets, right? Like, what does it actually do? And then two would be how well the system was designed to meet those requirements, because you could have two equivalent systems in terms of how they function, but one of them could be an absolute nightmare to maintain. And that's what gets back to the design principles that BJ was talking about, by not repeating yourself, not copy and pasting, those kind of things. But yeah, I've talked to some programmers who work on vehicle simulators, for example, and they've spent years getting to learn one code base, right? And so it just depends on the depth of what you're really doing.
Right. Yep.
And at that point, you're honestly becoming specialized in that subject matter as well, not just the programming side of it.
Yeah.
I will say the more you do it, the more you can handle.
Yeah, probably, yeah, you'll be able to optimize it better as you keep doing it, right? I mean, I think so.
Yeah, and the nuances of the language no longer slow you down, right? So like you get to a point where it's just a matter of what's actually on the page, not necessarily, you know, remembering. Like sometimes if I switch a language, if I'm not really used to it, it's been a long time, I'll have to actually spend some time remembering like what the syntax in a particular language means, right? And that takes away from time of you actually trying to digest what that line of code is doing. So your first barrier, right, is actually getting past the language, and then your second barrier is understanding the logic that's being described by it.
Yep. All right. Any other questions? Can always talk about them Thursday too. But yeah, Thursday's gonna be cool. You guys are gonna like it. We're gonna be doing machine learning on Thursday. We're gonna be doing AI, all the buzzwords. Good stuff.
Right?
Okay.
All
Yeah.
right, guys. Thanks.
Right. Thank you, guys.
Hey, guys.
Yeah. Yeah.
Have a good one,
Thanks.
guys.
Yeah. Good.